In this part of the unit current electricity, you will learn about the relation between current and drift velocity. So in the diagram, a conductor of length L is taken. Its area of cross section is A. Its ends are connected across the terminals of the battery having terminal potential difference V. I current is flowing through it, and the direction of flow of current is opposite to the direction of flow of electrons. Now N be the number density of the electrons, means number of electrons in unit volume of this conductor. So how much is the volume of this conductor? A into L. So total number of free electrons in this conductor will be NaL. So how much charge will be contained by these free electrons? Multiply it with charge of electron. That will be NaL into E. That is Q. And these many electrons are crossing this conductor in certain interval of time. That time is T. How much will be that time? Distance by drift velocity of the free electrons. L is the length. L by Vt is equal to T. Now how much current will flow because of flow of these many electrons? That will be I. How much will be I? I will be equal to Q by T. Put up the values of Q and T in this relation. You will get I is equal to ALNE by LVT is equal to NEAVT. This is the relation between current and drift velocity. Current and drift velocity. Once again you can understand the length of the conductor is L, its area of cross section is A, N is the number of free electrons in unit volume of the conductor. The total volume of the conductor is A into L. So total number of electrons and the charge contained by the conductor will be NaL into E. So time taken to cross the conductor will be L by Vd. So how much current will be flowing? Q by T. Putting up the values, you get I is equal to NeAVt. This is the relation between current and drift velocity. Very important relation. Now come to the next topic, that is Ohm's law. In this circuit diagram, a primary cell, that is Leclanché cell, is connected. Its terminals are connected across the ends of a resistor having certain resistance R. You will learn what is resistance in this topic. And an ammeter is connected in series to this resistor, and voltmeter is connected in parallel to this resistor. Variation of current is shown with voltage. How current varies with voltage is shown in this graph. You can see V is increasing, I is also increasing in proportionate manner. That will be reflected in this graph also. If V is increasing, I is also increasing. This straight line shows the relationship between V and I. So V is directly proportional to I. If we convert it into equality sign, is equal to Ri. What is R? R is resistance. So you can see IV relation or VI relation. So what is Ohm's law? The current flowing through a conductor is directly proportional to the potential difference applied across its ends. What is the condition? Condition is that temperature should be kept constant and mechanical strain etc. should remain unchanged. In that case, V is directly proportional to I, is equal to R into I. R is a constant called resistance of that conductor. So what is resistance? Resistance of the conductor is the property by virtue of which it opposes the flow of charge through it. Because of resistance, it opposes the flow of charge. So SI unit of resistance is ohm. Its a symbol is shown in this expression. You know the relation between current and drift velocity. I is equal to NEA Vd. What is Vd? Drift velocity is equal to minus E into electric field by M into tau. Minus sign shows that the Vd is opposite to direction of electric field. Now this electric field is potential drop per unit length, V by L. Put up the value. So Vd is equal to Ev by ml into tau. Only magnitude of this Vt is taken. Put up this value of Vd, drift velocity, in above relation. So we get I is equal to NEA Ev by ml into tau. So we can modify it. We can write V by I is equal to ml by Ne square a tau. Ne square a tau. So m by Ne square tau into L by A is resistance. R is equal to this much. So this term within the bracket is a constant term. This is called resistivity or specific resistance of the material of that conductor. Specific resistance. So if L is equal to 1 meter, A is equal to 1 meter square, then rho is equal to R. So specific resistance or resistivity of a conductor is the resistance of a wire of length 1 meter and area of cross section 1 meter square. So resistance of a wire of unit length and unit area of cross section is called its resistivity. Its unit is ohm meter. Its unit is ohm meter. That's all about this topic.